Welcome to this presentation on a novel single-layer high-isolation dual-band MIMO antenna designed for Sub-6 Gigahertz 5G and Wi-Fi applications. Authored by Yem Vu Van and colleagues, this research introduces a compact two-port radiator utilizing strategically placed shorting vias to achieve exceptional port isolation within a strictly single-layer substrate architecture. Modern wireless systems demand MIMO configurations to enhance channel capacity and mitigate multipath fading. However, achieving high port isolation in dual-band patch antennas traditionally requires bulky multi-layer profiles or complex decoupling networks. The primary objective here is to mitigate mutual coupling at both operating frequencies while retaining a low-profile, single-layer geometry. The foundational radiating element consists of 4 slot-loaded square patches, capacitively excited by a central probe-fed rectangular patch. As depicted in Figure 1, the overall two-port dimension is highly compact, measuring just 0.94 by 0.47 by 0.02 wavelengths at the lowest operating frequency of 4.6 GHz, separated by a narrow gap. To understand the dual-band operation, we examine the surface current distributions in Figure 3. Loading the square patches with slots disrupts the fundamental symmetry, forcing surface currents along diagonal paths. The 4.6 GHz resonance aligns with the embedded slot path, while the 5.6 GHz resonance excites the orthogonal diagonal vector. To suppress mutual coupling, shorting vias are strategically inserted, acting as localized LC band stop filters. Figure 9 illustrates this decoupling matrix. Vias placed at the patch corners effectively neutralize the dominant lower band coupling. Additional vias target areas of intense high-frequency interaction, drastically improving isolation without requiring physical decoupling footprint expansions. Analyzing the simulated and measured magnitude of S parameters in Figure 12 confirms exceptional performance. The antenna achieves measured return loss bandwidths of 2.1% for both the 4.6 and 5.6 GHz bands. Correspondingly, the inter-element isolation exceeds 25 decibels across both operational ranges, peaking above 30 decibels. Radiation characteristics are highly stable. The prototype delivers a peak gain ranging from 4.8 to 6.8 dBi across the dual bands. Furthermore, the envelope correlation coefficient approaches absolute zero, validating excellent diversity performance. A comparative analysis in Table 1 proves this design outpaces existing literature in balancing isolation, gain, and compactness. In conclusion, the single-layer MIMO antenna successfully bridges the gap between hardware simplicity and robust electromagnetic performance. By leveraging via loaded bandstop structures, it drastically suppresses mutual coupling. Delivering stable broadside radiation, high isolation, and a compact footprint, it is an optimal hardware candidate for upcoming 5G and Wi-Fi network deployments.